Hello everyone. Today, we the students of Gurunanak College of Pharmacy are going to present on the topic structure and medicinal uses of naphthalene, anthracene, diphenylmethane, triphenylmethane, phenanthrene and their derivatives. Triphenylmethane, phenanthrene and their derivatives. Group members of our group are as Shweta, Mansi, Sakshi, Divyani and I Rishika. So now let's begin. Over to you, Shweta.
Good morning everyone. I am Shweta and I am going to tell you about the structure and uses of naphthalene. Molecular formula of naphthalene is C10H8. It is one of the largest constituent of coal tar. It is the simplest fused ring system in which two aromatic rings are sharing a pair of carbon atom. As we can see in the structure of naphthalene, it has two cyclic structures. Hence it is a bicyclic compound. And it is the simplest form of polynuclear compound. IUPAC name of naphthalene is bicyclo in square bracket 4.4.0 deca 1,3,5,7,9 pentyne. The examples of monosubstituted naphthalene are alpha-naphthol and beta-naphthol, whereas polysubstituted naphthalene are 1-methyl-4-nitronaphthalene and 1,8-dibromonaphthalene. Naphthalene is an aromatic compound as it follows the following postulates of Huckel rule. First of all, naphthalene molecule is a cyclic molecule, which means it has a ring system, hence following the first criteria. The molecule is having total 10 pi electron in the ring system and following the second criteria, 4n plus 2 electron where n is equals to 2. All the pi electron are fully delocalized in the ring system of naphthalene molecule. It is having a fully conjugated system with all the carbon atoms sp2 hybridized, hence following the third criteria. Naphthalene molecule is a fully planar molecule, which means all the atoms are in the same plane. Thus, it is following the third criteria as well. As we can see in the structure given below, above and below the plane, there is a cloud of pi electrons formed by overlap of p orbital and are shaped like figure 8. Now we will see the properties of naphthalene. Naphthalene is a white crystalline or colorless crystalline solid. It is usually stable. Its heat of combustion is 61 kilocalorie. It is insoluble in water but soluble in organic solvent like alcohol, ether and benzene. This is a diagrammatic representation of resonating structure of naphthalene. As we know, the double bond present in the ring undergo delocalization by intramolecular electron transfer to attain stability. Now I will tell you about the uses of naphthalene and their derivatives. First, naphthalene is used in the production of phthalic anhydride and in synthesis of many 920 dyes. In household, naphthalene is used as a fumigant. Nadoxil drug is used as a beta blocker. Sulfonated naphthalene is used as surfactants. Amino-naphthalene sulfonic acid is used in synthesis of synthetic dyes. Naphthalene drug act well in curing the cough, urine infection, eye trouble and fever. Naphthalene sulfonic acid are used to make plasticizer, dispersants in synthetic and natural rubbers, tanning agent in leather industries and in agricultural formulations. The next structure will be explained by Mansi. Thank you.
Okay, so moving on to the next structure, which is anthracene. I will tell myself Mansi and I will tell about anthracene and its uses. Its molecular formula is C14H10 and its IUPAC name of anthracene is tricyclo in bracket 8.4.0.0 3 raised to the power 3,8 tetradeca 1, 3, 5, 7, 9, 11, 13 heptane. Anthracene is also called as paranaphthalene or green oil. It is a solid polycyclic aromatic hydrocarbon and consisting of 3 benzene rings derived from coal tar, and it is the simplest tricyclic aromatic hydrocarbon. Here all the carbons are sp2 hybridized in this structure. CH bonds are formed by overlapping of sp2 and s orbitals here, and the CC bonds are formed by overlapping of sp2 and sp2 orbitals here. Not all carbon-carbon bond lengths are equal because C1, C2 have more double bond character, which means the bond length will be shorter than the C2, C3. Here it is 4 pi electron delocalized system because all the 14 carbons are sp2 hybridized and ring has 14 p orbitals of carbon. That's why. Now moving towards the resonance in anthracene. Anthracene is a resonance hybrid of 4 canonical forms. Here we can see. It is less aromatic, less stable and more reactive than benzene. So why it is like that? Because resonance energy of anthracene as a whole molecule is 84 kilocalories per mole, and so the resonance energy of each ring will be 84 divided by 3, which is 84 kilocalories per mole, which is less than the resonance energy of benzene, which is 36 kilocalories per mole. So the lesser the resonating energy, lesser will be the aromaticity, and thus anthracene is less stable. It belongs to the Kekulé type of formula. It has been proven because it has aromatic character. It undergoes electrophilic substitution reactions like halogenation, nitration, sulfonation, similar to benzene and naphthalene. Also because of the presence of 3 fused rings, upon oxidation with dichromate and H2SO4, it gives 9,10 anthraquinone, which indicates the presence of 3 benzene rings fused in ortho position. Haworth synthesis, phthalic anhydride upon reaction with benzene gives anthracene. Here are the properties of anthracene. Anthracene is a white to yellow solid with a weak aromatic odor. It is soluble in water. Most of the chemical reactions are substitution, but it shows addition reaction also due to less aromatic than benzene. It shows strong blue fluorescence when exposed to UV light. This fluorescent property of anthracene is used in the criminal detection work, since a small amount of finely powdered anthracene on clothing, skin, money, etc. is not detected under ordinary light but easily noticed when exposed to UV light. So this is the advantage of anthracene. Here are some of the medicinal uses of anthracene. Anthracene derivative anthraquinone is a precursor in synthesis of dyes, red dializarine, which is also called as moderant red 11, benzothrones, etc. This is the structure of alizarine. Oxidized anthracene is a basic component of aloe and has anti-inflammatory properties. It is also used as additive in wood pulping and as a hydrogen carrier in H2O2 production. Diphenol, which is also a derivative of anthracene, is used in skin disorders. It impairs DNA replication and decreases cell division and is effective for healing psoriatic plaques, and which is antifungal. Anthracene derivatives act as good anti-cancerous drugs, for example doxorubicin, diethanol, etc. Given below are the structures of the following. Here are some of the other uses of anthracene. Drugs like Scana, Cascara and aloe contains anthraquinone as a glycine part for cathartic or laxative activity. Many herbal drugs contain anthracene and its derivative for anti-malarial, anti-HIV, antiviral and diuretic effects. It is used as wood preservative. Also it is used as insecticide in agriculture. It is commonly used as UV tracer, and also it is used as a scintillator for detectors of high energy photons, electrons and alpha particle. That's it for anthracene, and next structure will be explained by Sakshi. Over to you, Sakshi.
Okay, thank you, Mansi. Good morning, everyone. Myself, Sakshi. I am going to explain the structure of diphenylmethane. So, first of all, the molecular formula of diphenylmethane is C6H5 twice CH2. Diphenylmethane is an organic compound consists of methane wherein 2 hydrogen atoms are replaced by phenyl groups. IUPAC name of diphenylmethane is 1,1-methylene dibenzene. So it is colorless oil. So here the structure of diphenylmethane, where the 2 phenyl groups are attached to the CH2 group. So next slide. Okay, now the properties of diphenylmethane. Its melting point is 22 to 24 degrees Celsius and boiling point is 264 degrees Celsius. On nitration, diphenylmethane gives 4,4-dinitrophenylmethane. And on bromination, it gives a product named diphenylmethylbromide, which on using Zn or KOH reagent gives the product benzihydrol. And on oxidation with chromic acid, it gives the benzophenol. Now there are some medicinal uses of diphenylmethane and their derivatives. The various derivatives of diphenylmethanes are prepared and are successfully used as antispasmodic, means used to relieve spasm of involuntary muscle, anti-ulcer, which means tending to prevent or treat ulcers and especially ulcers of the walls of stomach or duodenum. Then antihistamine means used to treat the allergy. Then anti-anxiety means used to treat symptoms anxiety such as feeling of fear, dread, uneasiness, muscle tightness that may occur as a reaction of stress. Okay, thank you. That's all from my side. Now over to you, Divyani, for explaining rest of the structures.
Okay. Hello everyone, myself Divyani. Now I am going to explain you the structure and uses of triphenylmethane. The molecular formula of triphenylmethane is C6H5 by 6 by 3CH. It is a colorless solid organic compound containing methane group in which hydrogen atoms are replaced by phenyl group. You can see the structure on the screen. The IUPAC name of triphenylmethane is benzhydryl benzene. Now the properties of triphenylmethane. Its melting point is 92 to 94 degrees Celsius and boiling point is 359 degrees Celsius. It is a colorless solid. It is soluble in non-polar organic solvents. It is the basic moiety of many synthetic dyes like malachite green, magenta, crystal violet, and etc. Many of them are the pH indicators. Now this uses of triphenylmethane. It is mainly used in the preparation of dyes called triaryl methane dyes. They have the poor resistance to light and to chemical bleaches and are used chiefly in copying papers, in hectographs and printing inks, and in textile applications for which light fastness is not an important requirement. Some are used as a pH indicators and some display the fluorescence. This is all.
Thank you, Divyani. Now I will explain you about phenanthrene. Molecular formula of phenanthrene is C14H10. It is a colorless crystalline substance obtained from coal tar. It is isomeric with anthracene. It is a fused ring polynuclear angular hydrocarbon. As you can see here is the structure of phenanthrene and 5 canonical structures. Next. Now its properties. Its resonance energy is 92 kilocalorie per mole. Its solution in benzene shows blue color fluorescence. It is very reactive on its 9th and 10th positions. The carbons in phenanthrene are sp2 hybridized, having 14 pi electron delocalized system and is aromatic in nature. The key difference between anthracene and phenanthrene is that anthracene is less stable compared to phenanthrene. Next. Now, uses of phenanthrene. Phenanthrene is used to make dyes, plastics, and less toxicity pesticides, smokeless powder, explosives, and drugs. It has been used to make bile acids, cholesterol, and steroids. Phenanthrene occurs naturally as well as man-made chemical. Animal studies have shown that phenanthrene is a potential carcinogen. Carcinogen is an agent with the capacity to cause cancer in humans. Perhydrophenanthrene is used in production of jet fuels. Phenanthrene is also used for synthesizing alkalosis morphine and caffeine dimethylmorphine. So here we conclude with our presentation. Thank you very much.